Now we're going to take a look at area under the normal curve. So I have the basic normal curve up right here. And if we wanted to know what is the area under this curve, so we would shade in the whole curve, nice and neatly there. The area under the curve is going to be 1. Just like many other things in probability and statistics, the area of the standard normal curve, in fact any normal curve that you'll work with, is going to be 1. And the reason is then that any part of the curve that you shade is going to represent some part of the whole, some fraction of 1. So let's take a look at an example that does that. Here it wants us to find the area under the curve for z trapped between -2 and 1. So if I were to do that, I would draw my lines at -2 and +1. I'm going to set up my endpoints. I'm going to draw those under the curve here. So I'm going to go from my baseline up to the curve. And then I'm going to shade in the region that I care about, where z is trapped between -2 and +1. Shade that in here. And now this is the area that I want to find. Just looking at it visually, it looks like it'll be probably something a little more than 1/2. But it's hard to tell exactly what it'll be. And in fact, it's fairly difficult to actually calculate this too. There are shortcuts out there, but the easiest way to go about doing this is to use your calculator. So using a TI-83 or 84, there's a function called normal CDF. And in this function, we're going to type the z-score on the left side and the z-score on the right side to solve the problem. So in this case, the z-score on the left side is a -2, and the z-score on the right side is a 1. And we get that just by looking at our original problem without even looking at the picture. So we're given a -2 and a 1. Let's go ahead and write that in. So -2 and +1. Now we need to take out the calculator. You're going to want to go to second and the vars key. So you're really going to distributions, so second vars. And if you go down 1, the second one here is normal CDF. So hit enter. And you're going to go left, comma, right. So our left z-score we said was -2. And then our right z-score was +1. So we type that in, hit enter, and we're going to get 0.819 roughly if we round to 3 decimal places. So 0.819, drag that in there. That's the area in the yellow shaded region. So about almost 82% of the total area under the curve is being trapped between these two endpoints. Now let's take a look at an example when we're only going one direction. We're not trapped between 2 points, but we're just saying, for example, find the area under the curve for z is less than -1. Or z is less than +1, excuse me. We can draw our bound here at z equals +1, and then everything less than that we'll have to go ahead and shade in. Quickly do that here. So once you have your rough sketch of the area you're looking to find, you have a pretty good idea. Okay, again, it's going to be probably more than half, so more than 0.5, maybe 0.8 again, something roughly in that neighborhood. But when we type it into our calculator, it still needs a left and a right. Since this goes on forever, we're just going to pick a really big number in this direction. So I guess since we're going negative, we're going to pick a really small number to represent negative infinity, since our calculator doesn't have the number infinity in it. So if we go with, let's say, -1000, that's going to be sufficiently far out that it's not going to change our answer whatsoever. So for our left side, because it really technically goes on forever, we're just going to give a number that's really, really negative. So Let's call that negative 1,000. And then on the right side, we know we stop at 1. So our left bound is technically negative infinity, but since we don't have that in our calculator, we just pick negative 1,000. And then on the right side, we know we stop at 1. So again, we take out our calculator, we go to second, bars, go down to normal CDF. We're going to go negative 1,000, comma, 1. And it's going to give us 0.841 approximately. So the second answer here, 0.841, is going to correspond to the area in the yellow shaded region. Let's try one more example here. Find the area under the curve for z is less than negative 2. Well, if we go to our negative 2 here, and we draw our line, z is less than negative 2 is going to correspond to all of this area. And in order to find that, we need to know our left bound and our right bound. Once again, our left bound is going to be negative infinity, so we'll just pick, say, negative 1,000. Note that if we're going from a certain point in up, we would use a right bound of positive 1,000 and a left bound of whatever our number was, but this example here is just going this direction here. And then we would take our right value and we would make that negative 2. And now we pop this in our calculator one more time. Second, bars, go down to normal CDF, and we would go negative 1,000, comma, negative 2. And it's going to be something fairly small. So 0.022 actually seems fairly reasonable given how little of the area is actually being shaded here. So we're saying the area is going to be about 2% of the curve. Moving on, let's look at an example kind of like the standardized test example from before. So now our mean score is 600, our standard deviation is 40, and we want to find the proportion of people who scored above a 580. Well, 580, first let's go ahead and draw our picture because that will help us with the sketching and help us have a better idea of what we're actually doing. So our mean, 600, let's put that in there. Standard deviation is 40, so we go up 40 at a time and go down 40 at a time. Proportion of people who score above a 580. Well, 580 is going to be right here, halfway between 560 and 600. And we are saying find the proportion who score above. So we're going to shade to the right, because above is to the right. And then that'll be our region here, roughly. Now, what is the z-score statement? Since we don't have z-scores in the problem, we need to go ahead and convert our numbers into z-scores. So if this is our mean, our z-score of 0, and this is negative 1, we're looking at something roughly halfway in between. So our intuition is going to say about negative 0.5, negative 1/2. If we use our formula, we're going to go ahead and have our x value, the number that we care about, minus our mean over our standard deviation. So let's take that and write that out. 580 is the x value, the number that we're interested in. We're going to subtract our mean of 600. And then we're going to divide that by our standard deviation of 40. So that's going to equal a negative 20 over 40, which is exactly what our guess was before, negative 0.5. That's their z-score. So z is equal to all of this. So z is equal to negative 0.5. So if that is, I'm going to label that on there, negative 0.5, then when we do our normal CDF to get the area under the curve, we're going to punch in negative 0.5 as our left bound, because that's the left side here. And then the right side goes on to positive infinity, so again, we're just going to use 1,000. This time it's going to be positive 1,000 because we're going to the right. Clear our screen here. If we go to second bars, normal CDF, negative 0.5, comma 1,000. Hit enter, and you're going to get a value of 0.69, something a little bigger than half, given our halfway point is here. A little bit bigger than half makes sense. So 0.69 seems like a reasonable proportion. So the answer to the actual question, find the proportion of people who score above a 580, is going to be 0.69. Now, one thing that you might have noticed is that all of the problems were written as greater than. I'll just flip through these real quick. All the problems we looked at were written as greater than statements, not greater than or equal to or less than or equal to. Because the normal curve is a continuous function, there's actually effectively no difference between greater than and greater than or equal to. So whenever you see either statement, you can do the same procedure. And that's all for finding the area under the curve.